Hi guys, welcome back to grade 11 tutorials. So we are going to solve these questions. Okay, let's try to continue with 1.1.5 and see what we are going to get. X minus 1, the plus of 3, which is equals to x minus 4. So the best thing to do now is to simplify, this equation so that we can be left with maybe, the one that has the square root and the one that that is actually simplified. So x minus 1, I'm going to take 3 to the other side, which is equals to x minus 3 will be minus 7, right? So this gives us the opportunity for us to square both sides so that we can cancel the square root. I think last time I told you that the square root here is just equivalent to 1 over 2. So when you multiply that by 2, you are getting rid of the square root, right? So this will be x minus 1, which is equals to, so x, let me just expand it. So x times x will give us x squared, and then x and 7, negative 7x, and then negative 7x. Then this will be positive 49, if I'm not mistaken. Let me try to get the calculator and see. 7 times 7, 49. So meaning that 7 times 7 will give us 49, the plus of 49. So meaning that now x squared minus 14, the plus 14x, let me go back a little bit, plus 49. So we have this part, so when we take this to the other side, it will be positive, meaning that it will add to 49, and then this will be negative, will add to 15. So this means that we are going to have 0, which is equals to x squared minus, then this will be negative, and then we're going to get 15, and then this will be positive, then we're going to get plus 50. So now it's actually our time to deal with this. This is very simple because 10 times 5 will give us 50. When we add them, we're going to get 15. Very straightforward. So let's try to have the vectors negative 5 and then negative 10 equals to 0. Remember, negative times negative will give us positive 50. When we add them, we're going to get negative 15. And then x is equals to 5, or x is equals to 10. So this is what we get when we solve this. It's very straightforward solution. You don't have to get confused when you are dealing with it. Now it's actually our turn to move straight to the simultaneous equation, my favorite. So let's try to deal with it, right? So the first thing that I'm going to do is to create my first equation, and then after creating my first equation, then I'll come with the second one for substitution. So let's say that we have 3x minus y plus 2, which is equal to 0. Avoid the fractions. So I will now say that negative y, which is equal to, take this to the other side, negative 2, the other one to the other side, negative 3x. Multiply the entire equation by negative, we are going to get y, which is equal to 3x, and then the plus of 2. This will be my equation 1, and then the other equation will be y, which is equals to negative x squared plus 2x plus 8. So now if we decide to substitute this into this equation, which is like this is our equation 2, so then we can substitute 1 into 2. So this means that we can come here and substitute it here. So 3x plus 2 is equals to negative x squared plus 2x plus 8. So now it's actually my time to take this to the other side. It will be negative, meaning that before that, let me try this. Negative x squared, and then negative, this will be negative 3. So this will give us negative x, if I'm not mistaken. And then this to the other side will be negative, and then we give us a positive 6. So everything will equal 0. Let's try to multiply the entire equation by negative so that this can be positive. So this will now be x squared plus x minus 6, which is equals to 0. And now it's actually our time to simplify it. So I'm going to get something that when we multiply we get 6, when we add we get positive 1. Remember, if this is x, it means this is actually 1, equal to 0. So now let me see where we can write this. Let me just write it here. So 3 times 2 can give us this, and if we make this negative, when we add them we're gonna get 1, when we multiply them we're gonna get negative 6. Perfect. So meaning that x minus 2, then x the plus of 3. So these are actually our common factors. So now we can come here and say x is equals to 2, and then x is equals to negative 3, right? So remember, we are not done. We need to find the y values. So this implies that y is equals to 3 into 2 plus 2, and then this is equals to 6, then 8, right? So this will equal 8. So then here we have negative 3, so y is equals to 3 into negative 3, and then plus 2, and then this negative 9 plus 2 will give us negative 7. So that's how you can be able to solve this. Very straightforward. You don't have to waste your time when we're dealing with it. Let me erase the board. So now we can actually try to solve 1.3 that says show that the roots of this equation are real and rational for all values of k, right? So let me write it down. 3x squared the plus of k plus 2 times x, which is equals to 1 minus k, right? So the first thing that I'll do is to try to simplify what we have, and I'll say 3x squared plus, and then k plus 2, and then remember our x is outside, and then take this to the other side. We're going to have negative 1 plus k, which is equals to 0. So remember the roots, how to find the real roots. I think our part 1 has that if you've watched it, which is, so remember the formula, and then which is minus 4ac from the quadratic equation. So we have to identify b, and then 4a, and also the a and c. So we now know that our a will be here, and then we have our b, and we have our c, right? So our c will be this portion here, you see. Our c will definitely be this portion here. Please take it into consideration, and remember we are not including the x, we're just taking the values. So this is a value because the k should be something, and also this is a value, and also this is a value without any k or another thing. So which is equals to, what is our b? k plus 2, then squared minus 4, and then what is our a? That will be 3, and then what is our c? That will be, we can actually use k minus 1 actually, k minus 1, like this. Sorry. And then which is equals to, so when you multiply this by itself, k squared, this times this plus 2k, and then this times k, this times 2 again will be plus 2k, and then 2 times 2 will give us 4, plus 4. So this is what we have, and then this will be negative 12, right? And then remember that we have to multiply everything inside by 12, right? So let me try to say k squared, the plus of 4k, and then plus 4, and then this times k will be negative 12k, this times that will be positive 12, right? So let's try to simplify this. It's just getting complicated. 12 plus 4 will give us 16, and then negative 12 and 4 here will give us an 8, negative 8. So this is equal to k squared, and then plus k, negative 12 will give us negative, let me do this, will give us negative 8k, and then 4 plus 12 will give us plus 16. So if you check here, you will see that this will give us a perfect square, and the roots are real and rational in a way, because what can we multiply and get positive 16, and when we add them we should get negative 8. That will be negative 4 times negative 4 will give us 16, and when we add them we're gonna get negative 8. So meaning that we can come down here and say from this equation the solution will equal k negative 4 and then k negative 4, right? And this will imply that k negative 4 squared, meaning that this one here is a perfect square. So that's actually your conclusion, and that's how it is, that's how it works. I hope that you do understand how to be able to solve this. If you don't, please watch part 1 of the video, then that will definitely elucidate how it works.